I'm Pat Dugas. This screencast is about a method of solving quadratic equations analytically called completing the square, and it uses the square root property. Let's talk about the square root property for solving equations. So what we're going to try to do is create squares on both sides of an equation, and it may involve moving things from one side to the other. Once we've done that, we're going to take the square root of both sides and then solve and verify our solutions. This uses the square root property that if something is squared and we take the square root of it, we get the original quantity. Let's take an example. X squared plus 14x plus 49 equals 64. And we want to solve that using the square root property. On the left side is a perfect square because we have 7 squared, and so 7 plus 7 is 14. And then on the right hand side, we also have a perfect square. So we are going to factor the perfect trinomial. We're going to factor this trinomial here. And when we do, we get x plus 7, the quantity squared. Well, if we take the square root of both sides, we get x plus 7 equals plus or minus the square root of 64. Remember that when we take the square root, there's two possible solutions because a positive number multiplied by itself will give you 64, and a negative number multiplied by itself will give you 64. So since the square root of 64 is 8, we're going to simplify this to x plus 7 equals plus or minus 8. Next thing we'll do is use the subtraction property of equality to give us that x equals negative 7 plus 8, or x equals negative 7 minus 8. When we simplify that, we get two solutions. X could equal 1 and x could equal negative 15. We need to verify both of those by substituting into the original quadratic. If we take x squared plus 14x plus 49 equals 64, and we put in an x equals 1, and we put in an x equals negative 15 into both of those, we're going to test to see that we get 64 in both cases. So when we simplify f of 1, we get 1 plus 14 plus 49 equals 64. And then f of negative 15, putting in a negative 15 for x, we get negative 15 squared, which is 225, plus negative 210, because 14 times negative 15 is negative 210, plus 49. Is that equal to 64? Well, the left side equation is equal to 64, and the right side is also, so both solutions, negative 15 and 1, check out. Let's do another example. And because this one's not going to involve a perfect square on the right-hand side, we're going to wind up with what are called irrational roots, because we're taking the square root of a number that's not a perfect square. So x squared minus 4x plus 4 equals 13. Well, it turns out this is a perfect square already. 13, of course, is not. Nevertheless, we're going to go ahead and factor it. And when we factor this, we get x minus 2 quantity squared, because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4x. So negative 2x plus negative 2x equals negative 4x. So we get x minus 2 quantity squared equals 13. Now we're going to use the square root property, because the square root of something squared is the original something, and we get x minus 2 is either equal to positive or negative square root of 13, using that square root property. Last thing we'll do here, add 2 to both sides using our addition property of equality. That gives us x equals 2 plus or minus the square root of 13, which are both of our solutions. Now, but again, our two solutions, 2 plus the square root of 13 and 2 minus the square root of 13. That's what the plus or minus means. It can either be a positive or a negative. If we needed a decimal number, we could evaluate that on our calculators, and x winds up being approximately 5.61 or negative 1.61. Irrational numbers, 2 plus the square root of 13 and 2 minus the square root of 13. So in some cases, a technique called completing the square is useful. Let's talk about how that works. So completing the square is used on part of a quadratic equation that has x squared plus bx in it, and we're trying to complete that square by adding some constant term that makes it a perfect square. The way we do that is by finding half of this b term and then squaring that. Okay, and the reason for that is it works out with the distributive property of a binomial times itself. So step 1, find half of b and then square it. You're going to then add that result to the end and create a perfect square. This will probably make more sense when we do an example. But if we take that b over 2 squared, we wind up with the quantity x plus b over 2 quantity squared. Both of these are equivalent expressions. So by virtue of adding that b over 2 quantity squared to this x squared plus bx, we create this perfect square. And that's useful in using the square root property, as you'll see. So let's look at an example. Let's say we have x squared plus 4x minus 12, and we want to try to solve that using completing the square. So the first thing we're going to do is move the 12 to the other side, because we want to kind of create this ax squared plus bx to work with. Okay, and then we're doing that by the addition property of equality. We're doing that by the addition property of equality. That gives us x squared plus 4x equals 12. What we're going to do now is complete the square on that x squared plus 4x term. So we're going to take half of 4, that's the b term, and then square that number, and that's the number we're going to add to the right side. So we get 4 over 2, which is 2 squared, which is 4, positive 4. So we're going to take that positive 4 and add it to the x squared plus 4x term, thereby creating a perfect square. Now, it's an equation, so we got to keep it in balance. So whatever we do on the left side, we have to also do on the right. It's critical that you add the 4 to the left and the right to keep the equation balanced. When we do that, we create a factorable left side, which factors to x plus 2 quantity squared. And x plus 2 quantity squared does equal x squared plus 4x plus 4. It should always kind of just quickly distribute to double check. The right-hand side, 12 plus 4 is equal to 16. Okay, now we're ready to use the square root property. So we take the square root of both sides, and we get x plus 2 equals plus or minus 4. Last thing we do to get our two solutions is use the subtraction property of equality. And so our answers are either x equals 4 minus 2 or negative 4 minus 2. So our two answers are x equals 2 and x equals negative 6. Okay, so we'll do another example where the a term is not equal to 1. We do need to do an extra step in here to complete the square. So if we have 3x squared minus 2x minus 1 equals 0, the first thing we're going to want to do is go ahead and divide everything by 3, so the first term, the a winds up being 1. So if you divide everything by 3, you get x squared minus 2/3 x minus 1/3 equals 0. Now we're going to use the addition property of equality and add the 1/3 to both sides. When we do that, we get x squared minus 2/3 x equals 1/3. Now we've isolated the ax squared minus bx term. So we need to complete the square. We need to take this b term, divide it by 2, and square it. So we get negative 2/3, or over 2, squared. Okay, and when we do that, we actually wind up with 1/9. Okay, so now we add 1/9 to the left side, we add 1/9 to the right side to keep it in balance, and we've created a perfect square over here on the left. So when we take this, and we add the 1/9, we take this, and we simplify the right-hand side, we get 1/3 plus 1/9, common denominator of 9, we get 4 over 9. So x squared minus 2/3 x plus 1/9, which is a perfect square, equals 4/9, which actually is also a perfect square. We can rewrite this left-hand side as x minus 1/3 quantity squared, because when we square 1/3, we get a 9th. When we add negative 1/3 and negative 1/3 x, we get negative 2/3 x, and we have 4/9 over here. Now we're going to use the square root property and get this thing solved. If we take the square root of both sides, we get x minus 1/3 is equal to either plus or minus 2/3, because the square root of 4/9 is equal to the square root of 4 over the square root of 9, which is plus or minus 2 over 3. So that yields two solutions after we use the addition property and add 1/3 to both sides. Our solution is x equals 1/3 plus or minus 2/3. So it could either equal 1/3 plus 2/3, which is 1, or 1/3 minus 2/3, which is negative 1/3. Both are valid solutions of this quadratic equation. In this screencast, we've looked at a technique for solving quadratics analytically called completing the square, which uses the square root property.